All right, here goes our review from, oh goodness, number 18 through number 30. So I'm going to go through 13 of them. Number 18, which of the following is a factor of this expression? We go 2x squared plus 7x minus 30. We don't have a greatest common factor to factor out, so we're not going to worry about that. We're going to have to deal with our leading coefficient of 2. So if I think about what two binomials will multiply out to that trinomial, what do I need for my first terms? Well, x, the square root of x squared is going to be x, so I'm going to have an x here. And what are the possible factors of 2? 1 and 2. That's all I've got, right? It doesn't matter what order I go in, so I can put 2x and x there. Now I need to think about what factors do I have of 30. And I can make a list, 1 and 30. Because I have different coefficients for my first term, it's important to also reverse my numbers because order matters. 5 and 6, 6 and 5, and 30 and 10, 10 and 3, and as somebody pointed out, I forgot 2 and 15 and 15 and 2. All right, and I'm just going to start plugging them in and thinking about them. So if I multiply these out, I get x and 60x. That's not going to get me anywhere close to 7x. This will get me 30x and 2x. Whether I add them or subtract them doesn't get me anywhere close to 7x. 5 and 6. Let's see, that gets me 12x. That gives me 5x. Yeah, the difference of 12x and 5x is 7. So now I just need to figure out which one has to be greater, my positive or my negative. How do I know that I'm going to have one positive and one negative? Because this is a negative. So that's going to take a negative and a positive to multiply. So if I make this negative and positive, now I have a positive 12 and I have a negative 5. I add that together, I'm going to get 7x. Awesome. I'm done. These are my factors. One of those factors is x plus 6. Practice this with AA4. Number 19, select all of the expressions that are equivalent to this expression. What I did was I went ahead and multiplied out. What some other people did is they compared these, and actually I'm going to do that in a moment. But let's go ahead and take Roman numeral I, x plus 5 times x minus 2. Use FOIL, so my first gives me x squared, my outside give me negative 2x, my inside give me 5x, and my last give me negative 10. Combine like terms, I get x squared plus 3x minus 10. Nope, that is not what I'm looking for, so I can cross off I and A. Okay, number 2, or Roman numeral 2, I can go ahead and multiply this out. And let me fix that mistake that I made. This should still be a negative 10. And distribute in my negative, so I end up with negative x squared plus 3x plus 10, which is the term I was looking for, or the expression I was looking for. So 2 is a possibility. That means B, C, and D are still possibilities. For 3, I could again multiply it out, but hey, let's figure out an easier way to do this. Let's see if I just compare. I knew that 2 would work, right? I knew that 2 would work. Let's compare 2 and 3. X minus 5 is the same. The only thing different is these binomials, and this one has a negative. If I compare them, negative times x plus 2 versus negative x minus 2, well, isn't that just the negative multiplied back in? Yeah, and so if I add that x minus 5, that was the same. These are equivalent. So I could still have C and D. All right, so now we just need to check 4. And, well, if I compare, x plus 2 is the same. How about these? Negative x minus 5 and 5 minus x. Are these the same? Negative x minus 5 and 5 minus x. Well, if I distribute that negative in, I'm going to have negative x plus 5, which if I turn that around is the same as 5 minus x. If I use the commutative property, it's the same. So that means all these 2, 3, and 4 are equivalent to our given expression. You could practice it with ZZ8 and ZZ9. That is just multiplying binomials. What is the simplified form of negative 3b plus 7 squared? You could solve this a couple different ways. The way I solved it at first was to know the pattern. This is a binomial squared, so I've got a plus b squared equals a squared plus 2ab plus b squared. Well, what is a squared? That's negative 3b squared. The negative is part of that because it is in the parentheses here. So because of that, negative 3 squared is 9, b squared is b squared. So if I square that, I get 9b squared. So that's my first term squared. Plus 2ab, so 2ab. AB is going to be negative 21b, right, if I multiply these out. And twice that is going to be negative 42b. And b squared, that's 7 squared is 49. There we go. Other way to do it, if you're not comfortable by looking at the pattern, this is a special case, you could have just written them out and multiplied them. Again, though, you need to know this negative 3b and that negative 3b, those are part of the parentheses. Those matter. Okay, z.9. All right, find an equivalent form of this. 2 times the quantity of b plus 7 squared. A lot of people try to distribute that 2 in. You cannot do that. Order of operations says I have to deal with my exponent first. So I'm going to keep the factor 2 out, and I'm going to multiply this to get my quadratic, my trinomial. So I get 2 times b squared plus 14b plus 49. Now I can distribute my 2 in. 2b squared plus 28b plus 98. There's my answer. Practice with this, probably z6 and z8. But really the key here is order of operations. Remember, exponents before multiplication. 22. We're booking right along. I might have to separate this video. We'll see. The expression x squared plus bx plus c. So we're just given a general expression. Factors to the expression x plus p times x plus q. Okay, so they're giving us this p and q to kind of think about, where b, c, p, and q represent non-zero rational numbers. So there's no funny stuff here. They're just normal numbers. All right. And so we haven't seen many problems like this, right? That's because this isn't really a problem. This is an opportunity to investigate and explain the rules. What is it that we know? Well, if b is less than 0, which means it's a negative number, right? And c is less than 0, so that's also a negative number, then which of the following statements is true? Okay, if I look at these, you know what? None of these make sense to me until I see an example. So I'm going to pick an example where b and c are both negative. X squared minus 3x minus 4. So I took this expression and I replaced b and c with numbers that are negative. Okay. So if I factor this out, I'll have 2 binomials. And I know that one has to be negative and one has to be positive, right? I know that because this number is negative, because c is negative. All right, so I can cross off a and d, because both of those cannot be true. All right, and now b and c. It's asking me about one of the numbers, either p or q, their absolute value being greater than the other. So I'm comparing their absolute value. Okay, so let's look at b. b is a negative 3. What has to happen for me to get a negative 3 as opposed to, say, a positive 3? Well, if I plug numbers in, I know I'm going to get x's here. Again, I'm looking at an example as one of my strategies to try to work this out. And if I put 1 and 4 there, what am I going to get? I'm going to get a positive 4x, I'm going to get a negative 1x, and that's going to add up to be a positive 3x. So that doesn't work. If I put a negative 4 and a positive 1 in, now I get a negative 4x, and I get a positive 1x, and that's going to give me my negative 3x. All right, let's go back to this. P is positive, and Q is negative, where the absolute value of P is greater than the absolute value of Q. Okay, so let's see. The absolute value of negative 4 is greater than the absolute value of 1, right? Absolute value of the negative number here, in my example, is greater than the absolute value of the positive number here. Okay, how do I know which is P and which is Q? It tells me right here. P is positive. All right, so this is P, and this one's Q. And so which answer do I have? Absolute value of P. So I wrote them backwards. That's okay. Absolute value of P has to be less than the absolute value of q. So it's not B, it is C. I really don't have an IXL practice for you on this one. You're just going to need to, if you see one like this, you're just going to have to reason it out. You guys have the algebra brains. You can face, you can power through things that look unusual. Use your logic. Okay, number 23. What is the sum of the solutions of this expression? And a lot of people, or sorry, this equation. And a lot of people, including me, looked at this and said, it's asking for the sum of the solutions? Is that some kind of weird special thing? No. They're actually literally asking you to add up the solutions. All right, so I'm going to solve this. X squared plus 8x equals 84. And I could, well, so the first thing I'm going to do is I'm going to set this to 0, right? So I subtracted 84 from both sides. And I'm going to go ahead and factor it out. I could complete, well, I don't need to, yeah, I could complete the square, but why? And I could worry about the quadratic formula, but why? I can factor this out. But I'm going to, so let's see. I know that that's an x and that's an x. What are possible factors of 84? 84 and 1, well, that's not going to work. 42 and 2, no, that's not going to work. 21 and 4, no, that's not going to get me my 8x. 14 and 6, yeah, the difference of those is 8. So if I make one positive and one negative, I'll get that. Now I just need to worry about which one is positive, which one's negative. Well, just like the last problem we did, it's the opposite of it. I need this to be positive. That means the absolute value of this number has to be greater than the absolute value of that one. So there we go, positive, negative. Right, but I'm not done yet, am I? I need to identify the sum of the solutions. Oh, so I still need my solutions, don't I? So let's see. Zero product property says that one of these factors, one of these binomials, has to be equal to 0. So that could be the first, x plus 14 could equal 0, or x minus 6 could equal 0. Why is that the case? Because I'm not going to get 0 as a result of these products unless one of them is 0, right? There's no other numbers that could give me 0. All right, solve for x on each one. X equals negative 14, or x equals 6. Those are my two solutions. I need to add them up. Negative 14 plus 6 equals negative 8. There's my solution, or there's my answer to the question here. BB5 is probably what you want to work with here. Okay, solve for x. 16x squared minus 49 equals 0. Okay, 16x squared minus 49 equals 0. I could try to factor it out, but actually that wouldn't have been too hard. But no, I'm not going to do that. I could deal with a quadratic formula. Yeah, that wouldn't be too hard either, but there's too many ways to make mistakes with a quadratic formula. This is a perfect square and this is a perfect square. Why don't I just solve by taking the square roots? So first thing I'm going to do is I'm going to move 49 to this side. I'm going to add 49 to both sides. And now some students smartly pointed out, if I stop here and take the square root on both sides, I'm okay. I decided to make it more difficult for myself, and I divided both sides by 16. So now I have x squared equals 49 over 16. The next step is where most people trip. Take the square root on both sides. I get x equals plus or minus radical 49 over 16. Remember that plus or minus is important because if you just talk about the square root, the symbol means we're talking about the principal square root, which is positive only. That's why we add this. All right, so let's see. I can't simplify this, so I'm going to say x equals plus or minus radical 49 over radical 16. Hey, these are both perfect squares. So that's x equals plus or minus square root of 49 is 7. Square root of 16 is 4. There is my solution. There are my solutions. Positive and negative 7/4. There we go. To practice this, BB4 would probably be good to practice it. Okay, the height h in feet of a person jumping off a diving platform. Man, we like those divers, don't we? Can be modeled by the equation x equals negative 16t squared plus 4t plus 6, where t represents the time in seconds the person is in the air. After how many seconds does the person jumping off the platform enter the water? All right, I'm going to start with an illustration. There's my platform, there's my water, there's my jumper. So artistic. Okay, let me think about where this falls on the axes. So there's going to be the start, so that's where x equals 0, so that's my y-intercept. Here's where it hits the ground, or the water, rather. Oh god, the ground would be painful. The water, which means y equals 0 here. So there are my axes. And so when it hits the water, when the diver hits the water, he or she, I guess, that is our x-intercept, and that means y equals 0. So we have a couple different ways to solve this. But the most important thing is that now I know that the height for our solution to the question is 0, right? Because that's when it hits the water. Our height is 0. So we're looking for t. How many seconds does that take? All right, so let's plug that in to our original equation. 0 equals... All right, you can solve it a couple different ways. I'm going to start by factoring. So the first thing I need to do is factor out the greatest common factor. So I get 0 equals greatest common... First of all, I need to factor out that negative, right? And then the greatest common factor is 2. So negative 2, I'm going to factor that out. I get 8t squared plus 2t minus 3. Okay, so now I'm going to look for negative 2, and what two binomials can I multiply to get that trinomial? I'm going to start over on this end this time, because what two factors can get me 3? 1 and 3, that's it. So I'm going to put those in now. I know those. Now I'm going to worry about what factors can get me 8. 1 and 8, 8 and 1. Remember, order matters because these are different. 2 and 4, 4 and 2. And that's it. All right, so I know that I have a t on each of those because I have a t squared. Or, sorry, look here, a t squared there. 1 and 8, does that work? No. 8 and 1, does that work? 24 and 1, no. 2 and 4, does that work? Let's see, 2 times 3 is 6t. 1 and 4 is 4t. Yeah, the difference of 6t and 4t is going to make it. So there we go. It's 2 and 4. Now I just need to think about which one of these is going to be positive, which one's going to be negative, because that number is negative. So let's see, if I make that one negative and that one positive, that gives me a negative 4t. That gives me a positive 6t. If I add those up, nope. Let's reverse those. That's positive 4t, negative 6t. I add those together, I'll get a negative 2t. All right. So now that I've got that, I'm going to use the zero product property. Because if this is 0, then either, well, negative 2 can't be 0, right? So that means either this binomial equals 0 or this binomial equals 0. So I'm going to set both of those equal to 0. And I'm going to solve for t. I got a t is negative 1/2. No such thing as negative time, right? So that's not the right answer. How about this one? Add 3 to both sides. Divide both sides by 4. T is 3/4, so 3/4 of a second. There's my answer. But Miss Decker, couldn't I just use the quadratic formula? Sure, here we go. Quadratic formula. I could also complete the square, actually, right? I could. I don't know why I'd want to, but I could. And I could, there we go, quadratic formula. So A, B, and C. T equals opposite B plus or minus radical or square root of B squared minus 4 times A times C divided by 2 times A. Now I'm going to tell you, the number one mistake people are making is when they multiply these in the discriminant, they're getting the wrong sign. So they're adding when they should add, they're subtracting when they should subtract. I also saw some people multiply all these terms. Don't do that. We're subtracting. So this is B squared minus 4 times A times C. All right, so I'm going to take it step by step. T equals, opposite 4 stays that way, plus or minus radical 4 squared is 16. Negative 4 times negative 16 times 6 is 384. Divided by 2 times negative 16 is negative 32. Okay, let's go ahead and add this. So t equals -4 plus or minus 400 divided by -32. Let me make some room over here. So now I've got, well, what is the square root of 400? Plus or minus 20, right? So it's plus or minus the square root of 400, that's 20. So t equals -4 plus or minus 20 divided by -32. I could simplify this a little bit more, but I don't need to. I'm just going to go into my two solutions. One where I'm adding, one where I'm subtracting. So t equals -4 plus 20 over 32. T equals -4 minus 20 over -32. I'm going to solve the first one. Oh, look, I can already see I'm going to have a negative solution. That's not going to work for time. Let's see about this one. I'll just solve. And I get 3/4. Same answer, different way to get it. All right, to practice this, BB6 and BB9. Number 26. Given the equation and the graph of y equals -x² minus 1, what is the domain and range? You guys rocked on this one. First thing I know is this parabola is going to go on and on forever that direction, on and on forever that direction. That means that my domain, which remember is all possible inputs, are all real numbers. I could put in all real numbers, right? So I know D is not a possible answer. Okay, so it could still be A, B, or C. What's my range? Range is all my possible outputs, right? Well, if I look at this parabola, it goes on and on forever. Do I ever have an output up here? No. So my range, my outputs could be my vertex and everything less than my vertex, right? If it was opening up, it could be everything greater than my vertex, but it's everything less than my vertex. So in this case, my range is y is less than or equal to -1. There we go. To practice this, DD2, yes, they are absolute value functions instead of quadratic functions. Same principles apply here. Number 27. Which of the following quadratic functions represent the function graph below? So first thing I looked at is my slope. Well, not my slope, sorry, forget I said that. Is my A value, my changing rate of change, or my concavity. So let's see. If I have a concavity of 1/2, then I have a shallow. I have a compressed or widened or there's another word that I can't remember right now. And that's not what I have here, right? I have it being stretched. Like if I took a rubber band, it's being stretched. That means that my A has to be greater than 1. So it has to be B or D. All right, so let's look at my vertex. My vertex is 0, -5. If I look at vertex form, there's my HK. Vertex form is y equals 2 times, I know that that's 2, right? I just took it from there. X minus 0, there's my H, minus 5, because that's my K, -5. I'll just deal with my minus 0. I get y equals 2 times x squared minus 5. Which equation is equivalent to that? B. DD3, again, it's absolute value, but because you're dealing with vertex form, that would be a great thing to practice. 28. Easiest question on the practice exam, I think. Which of the following graphs represents this function? Well, we have a vertex of opposite of -4, so a h of 4, and a k of 3. Which graph has that? Not that one, not that one, not that one, that one. That's the only graph that had that vertex. So easy. DD3, though, if you want to sharpen your skills on this one. Most of you got it, but if you need to sharpen your skills, that's the way. Number 29. Almost there. Translate the graph of, there's our parent function. 4 units to the left, 3 units up, and vertically compress the graph by a factor of 1/2. Okay, so we know what these are, right? 4 units to the left means that our H or our K? Our H is going to be a -4, right? To move to the left, that's a negative. Okay, our K is going to be 3 units up means k will be positive 3. And our A is going to tell us our compression factor of 1/2. A is 1/2. Now I just need to plug it into the vertex form. But here's where a lot of people trip. Remember, the vertex form has subtraction in it. That means that when I put my h in there, I'm subtracting a negative. So f of x equals a 1/2, there's my a, times x minus negative 4 squared plus k is 3. Now I'm going to simplify this. Minus a negative 4 is going to be f of x equals 1/2 quantity x plus 4 squared plus 3. There's my answer. I could practice BB3. Last one. Number 30. Oh, so easy. Which of the following is for the vertex for this? There's my h, opposite of minus 5. H is 5, k is 2. So easy. 5 and 2. Just remember, h is the opposite of what it looks like, right? Because subtraction is in the vertex form. So 5, 2. There's my answer. To practice this DD3, again, I think it's absolute values, but it's the same vertex form, right? All right, see you in class. Thank you so much for watching this ridiculously long video or whatever parts you watched. Good for you.